All right, for those of you who are ready for this, I'm going to go over a couple of these and we're going to check this in class. This will go into your spiral after or before our little flip book on surface area and volume. So for trapezoid, you need to know the formula to calculate that. And the formula is A equals 1/2. Then parentheses, you have to add up your bases. So B1 plus B2, then times your height. So a couple things you need to make sure you recognize. In a trapezoid, your bases are always the parallel sides. You have a top and a bottom here. And your height is always perpendicular. So your height is the segment that makes the right angle with the bases. And so when we're looking for the height, we're always looking for that box. So I'm just going to go through some guided examples and a couple independent on below here. So in here, this trapezoid, your 10 could be your base 1, and your 15 could be your base 2, and your 6 would represent your height. So when we plug it into the formula, 1/2 base 1 plus base 2 times height, we're doing 1/2, and inside the parentheses would be our 10 plus 15 times the height. The height was the 6. So we're going to follow order of operations, which means we're going to add, our bases first. So we would get 1/2 of 25 times 6, or half of 6 times 25. So this area actually comes out to be 75 centimeters square. Okay. Now, for example 2, if you notice, I have one of the bases. 10 could be your base 1, but I'm missing base 2 down here. And I'm also missing the height. So in a situation like this, you're going to have to draw your height perpendicular here. And we're going to have to use the right triangle to find that height. So in this instance, because I know when I draw this right, just vertical line to make this right triangle, I create a rectangle here. And this opposite sides in a rectangle are the same. So I know at least I have 10 here. So now I'm going to use just the right triangle to find our missing short leg and then our height, our long leg here. So see if you can try to do that. See if you recognize that. All right, hopefully we saw half the hypotenuse here would be the short leg is 6, and that makes our height here 6√3. So now I can plug it in to our formula, and because we have a radical in our height, we're going to have a radical answer most likely. So we're going to do 1/2. B1 is our 10 plus B2. Now to get to this B2, we have to add these two parts together. So that's going to be 16 times our height, which was the 6√3. So we can simplify this as 1/2 of 26 times 6√3. I could take the 1/2 of 26 and then times it by 6, or the 1/2 of 6, doesn't matter. But the final answer, and I'm going to put it over here to the side, is 78√3. And that is inches squared. Okay. Inches squared. So what I want you to do is apply the formula to these trapezoids here. And it does say to leave in simplest radical form when that happens. So on the first two, you have your base 1, your base 2, and you have your height. Okay, so what you do, you want to recognize the part so you can plug it into the formula. Now on number 2 here, your base 1 is and your base 2 are actually the 3 and the 9. Remember, it's the parallel parts. And then our height, where that right angle is formed, our height would be the 8. Now, when we get to number 3, we have base 1 is 10, base 2 is 13. And just like our example 2, we're missing the height. So we're going to have to draw this vertical line and create that. when I do that, because I knew in this rectangle this is 10, well, this will also be 10. If I know the whole thing is 13, that means this little piece inside of this triangle is 3. And this is a triple. 3, this would be 4, and then 5. So now I have my height. And so you can plug it in. I do want you to see how well you can use your formula. 1/2 b1 plus b2 times the height to get your answer. But when you get to 4 through 6 here, our height is not listed, okay? We have to calculate that. So just have to remember that the height is missing and you have to use your right triangle to problem solve. You have to create that right triangle. So on number 4, I can create that right triangle by drawing this vertical line here, making it perpendicular. Doing just like I did on number 3, using the rectangle, that's 7, opposite side 7, which means this missing side would be 5 to get the base of 12. This is also a triple. It's 5, 12, 13. Now the height on number 5 here is this dotted line. And again, I'm going to use the 9 in the rectangle. And I'm going to use the hypotenuse in this 45 because it's going to be a 45, 45, 90 triangle, which means the legs are the same. So if the hypotenuse is 10 root 2, that means this legs, both of the legs, are going to be 10. So now I can see that the base here would be 19. And now I have my parts to plug it in. This is going to be a whole number answer. And for our 6, the height's missing. But I use this rectangle, these sides being 9. And then I use the right triangle, seeing this is 60, which means this over here would be 30. So my short leg is half this hypotenuse of 16, which means it's 8. So that means our height, which is this long leg, would be 8 root 3. This, when I plug it into my formula, 1/2 base 1, which is my 9, plus base 2, that's adding these two pieces together, which is 17, times the height, which was the 8 root 3. So gonna take half of 26 times 8 root 3. This comes out to be, let me extend this page here. The area is 104 root 3 inches squared. Okay, so that covers your trapezoids. On your next page, we're now dealing with rhombus and kite. They have the same formula to deal with that area. And so the area is 1/2 diagonal 1 times diagonal 2. And when we're doing the diagonal 1, it could be your long diagonal, okay? That's our diagonal 1 here, versus our short diagonal, okay? Sorry about that. Remember, the diagonals are always going to be perpendicular if it's a rhombus or a kite. Here, diagonal 1 here is our long diagonal. And then here is our short diagonal. And then they're bisected. And this is going to get cut in half as well. And the kite, your short diagonal is the only one that gets bisected. So if I look at this example 3, this 7 that they have is indicating this piece here. So I have to double it to get the long diagonal. So my diagonal 1 is going to be 14. To get the short diagonal, see we have that 5, so it's 5 on the other side. That's going to be 10. So we're going to plug it into our formula. Sorry. A is 1/2 diagonal 1, which is 10 or 14 times 14. So half of 10 or half of 14, this comes out to be 70 centimeters square. Now on example 4, they're pointing, this is a kite. So remember, the kite long diagonal doesn't get bisected. So this 3 is only this little piece here. And then this 10 is this piece. So the total diagonal 1 is 13. All right, let me make that better. But in the kite, the short diagonal, which is this 4, this gets bisected. So it's 4 on both sides. Diagonal 2 is 8. So now to calculate the area, we're doing 1/2 of 13 times 8. So this comes out to be 52 inches square. So on 7 through 15 here, we're using the diagonals to calculate the area. 7 through 9 here, this is a kite. And so again, add these two pieces to get diagonal 1 to be 14. And then the short diagonal, this gets bisected. So that is 18. We're doing diagonal 1 times diagonal 2. So same thing on 8. On 9 here, this distance of 16 that they're showing you, they're trying to get you to understand it's the same distance here. Okay, so this short diagonal would have been 8 and 8, but you just need the whole thing. And then now you can add these two pieces to get the diagonal 2, to get the second diagonal. Now, it's when we get to 10 through 15 here, because we're going to, it says right here, leave answers in simplest form. This is when we have to remember if the side or part is missing, we have to use the right triangle to problem solve. So on our first one, we have our 4, but this whole thing is going to end up being 8. And then same here, if I have this 6, the whole thing is going to be 12. So we don't need to do Pythagorean theorem or special rights with that. But on 11 here, this 9 is representing this piece, which is on the other side here. Remember, the diagonals are bisecting and they are perpendicular. So what is missing is the long diagonal here. So I'm going to have to use Pythagorean theorem to find that missing piece. We would do our a squared plus our b squared equals c squared. So this would be the 9 squared plus that missing leg squared equals 15 squared. And we're going to solve for the x. This is 81. 225, I believe. Subtract the 81. You get x squared equals 144, and then you have to take that square root. So that lets me know this is 12. And now that's 12, and now I have my whole diagonal. Okay. So on 12 here, what's missing is drawing the diagonal through the rhombus here. And I just kind of use this little tool to get it in there. And they gave us a short diagonal, which this gets cut in half to 8 and 8. And then now we're back to what we just did on number 11. Oops, that's not 12. It's supposed to be 17. So we need to use this hypotenuse. We're going to focus on just one right triangle. I'm going to use this one right here. Okay. I'm going to focus on how I'm going to find this missing piece using Pythagorean theorem. So I want you to see if you can do that just like we did on number 11. Now 13, now we're using our special rights. because we see this 45 degrees here. And the rhombus, those opposite angles are cut in half. So I already know we're going to have 7 and 7, so one of the diagonals is a total of 14. But if this is a 45, 45, 90 triangle, then that means these legs are the same. So that means the other diagonal would end up being 14 as well. And on 14, sorry, you just multiplying those, but on 14 now they're showing the 60. So this is a 30-60 triangle. And if you look opposite this 30, we have the 6, which is short leg. Okay, so we double that and get the hypotenuse, so this would be 12. And then to get the long leg, we take the short leg times √3. So this is 6 √3 for both sides. So diagonal 1, I can make that 12 √3. And then diagonal 2, that would just be 12. Okay. So C, now number 15, the 8 would be the hypotenuse in this 30, 60, 90 triangle. See if you can figure out the short leg, which is half the hypotenuse. Okay, and then just double it and see if you can figure out the long leg. This long leg is going to be a radical. So we're going to get a radical answer on this last one. All right, so finish the ones I didn't do. We're going to check this in class. Thank you for working on it. And I'll see y'all on Friday.